Hi, my name is Pavel Savenko. Welcome to a new Cube video. For this episode, I didn't invent any interesting puns. Therefore, I just announced that in this video I will present you another standard CubeGUI plugin, so-called metric statistics, which displays, as it says, statistics of different patterns which Scalasca Trace Analysis tools collects during the analysis. Let's do it. Okay, we are back into our terminal, and in this video I demonstrate you another standard plugin of CubeGUI, so-called metric statistics plugin, and hopefully show you which data does it deliver and how this might be useful for the performance analysis. So we open an example of a cube file, in this case a trace result of trace analysis. So that would be the trace cube X. And so we get the start screen. It is BT&Z benchmark. So we see here on the left side usual metric hierarchy. We see that it is already processed using remapping step. So we have here hierarchy of time and all other metrics. We have here call tree and system tree as usual. So this is example of measurement, so-called trace analysis of the measurement. This cube file is produced by Scalasca Trace Analysis tool, and in this video I'm not going to explain details how Scalasca Trace Analysis works. I take it for granted that you are familiar with the trace analysis and you also understand and knows functionality of trace analysis tool. If not, then I refer you to study videos of our partner channel of POP, or take a look into the training material of our virtual high productivity institute of high performance VHPS, and read about functionality of Scalasca trace analysis. Short and compressed, basically, the Scalasca Trace Analysis tool scans the result of the trace measurement, so basically OTF trace files, and looks for every situation where the application is not doing any calculation but waiting for some messages, for example. So example is late sender, for example. One rank started to wait for some message from another rank, but the another rank sender didn't start sending it yet because it's busy with computation, for example. So this is a typical situation of not balanced computation, and it leads to the waiting state in the second rank. So, and this Scalasca Trace Analysis detects all such situations and attributes them to corresponding call path, and basically says that this or that call path, like for example here, is waiting at the barrier, that is this MPR barrier, spend so much time waiting for till all ranks are entering the MPI barrier. So if in the case of not balanced situation, some rank entered MPI barrier call earlier than others, so now it has to wait till others execute this call. So this waiting time is attributed here and stored in the form of these various metrics. So Scalasca detects a lot of metrics. They are usually as a leaves in a metric hierarchy. So like here, for example, wait at the barrier completion. We have here late post, early wait, and so on, like in the communication of point to point, late sender, late receiver, which I mentioned before, late broadcast, and. So that is the first thing. The another thing is Scalasca Trace Analysis, of course, detects all these patterns in a trace, and it can happen that there are multiple patterns of, for example, late sender, like here, late sender, messages wrong order, or this one, and they are like, for example, here, but they appear on multiple times in multiple situations during the runtime in a trace. So in a trace, if we would have visualized the trace using Vampire or using Blade plugin, we would probably detect and see all these waiting scenarios. But Cube provides profile. It provides aggregated information about the execution. So therefore, the data which Scalasca stores in this matrix, like for example this wait at the barrier, 0.04 seconds, this is aggregated time of all patterns of waiting at the barrier. It might be multiple, maybe hundreds and thousands, and I don't know how many. And of course, it is important to know that yes, we spend a lot of time waiting at the barrier, and we don't spend that much time completing this barrier. We spend even more time in the late sender, and one has to estimate how severe is this problem and whether one has to address it. But nevertheless, one would like to know, is that accumulated, for example, this late sender, is it accumulated time? Or maybe there is one pattern where it particularly appears and it takes like 4 seconds, and all other hundreds of patterns, they are also minimal, and they are accumulated give only 0.3 seconds, for example. So that would be kind of a middle situation between profiling and tracing. And that is exactly what this plugin Metrics Statistics delivers. Scalasca Trace Analysis creates a special file and stores it in the very same measurement directory, where it stores five most severe instances of this waiting pattern with their data, and it stores also statistics for this waiting at the barrier. And this plugin, this metric statistic plugin, allows you to display this data. So as usual, at this moment I would say don't forget to subscribe, press a like, and put a question if you have any into the comments. So anyway, plugins that is the standard plugin. If it is not activated, one has to take a look here whether this metric it is called system statistics. This metric, this plugin is that. Whether it is activated. If not, then one has to put this box plot here. So to get the statistic about every of this metric, one basically has to press right button on the mouse, and one gets here two menu entries: show metric statistic and show max severity information. So, like for example, let's go on this late sender, and we click here, and we see the statistical information for all late sender patterns, and we of course see that the majority of these late senders, like we hear, there's a median is 0.4 milliseconds, and the maximum is however is 0.24 seconds. So obviously we have very unbalanced statistics. So we have one outliner, probably maybe few outliners, which are so severe, and majority of the late sender patterns they are in milliseconds area. So we know that it might be only one situation where this late sender has a biggest impact, and it's not basically every late sender has this value. If we take a look at another metric, like for example late receiver, we see that there is already more distributed, but nevertheless there is one late receiver which has maximal value 1.3 milliseconds, but majority of the late receivers are in a range of 0.1 milliseconds, so maybe negligible. If we take a look at the live broadcast, we see that here is the situation is already different. So there is no such outliner. Majority of late broadcast in this sense are in a range of 0.4 milliseconds, and maximal is also 0.41, 0.42. So probably they all are across the run equally distributed, and so on. One can also do multiple selection. If we select multiple, basically all of these metrics, and select show metric statistic, we see then all of them, all statistic at once, and they are numerated 1, 2, 3, 4, and here are the names of this metrics, so one can estimate more or less statistic at once glance by clicking at particular box plot. One gets the detailed information about the statistic, like sum, count, mean, standard deviation, and everything what one needs. Okay, another important information which this plugin displays is information about so-called this maximums. Like for example here, if we take a look at this late sender, we see that this there is one late sender pattern situation which takes 0.2 and 4 seconds. It may be one or two of them, or I don't know how many few of them, which are really outliners. Majority of them are really minimal, so they are probably not interesting for us. But we are now more interested in this outliner, this maximal late sender. So the way how to get information about it in the CubeGUI is, again, we right click on it, and here is show max severity information. So if you click choose it, we see the information about exactly this one pattern in timeline of late sender. So that is the call pass BT, exchange QBC, MPI wait all, and it has enters so it starts on 2.4 seconds and finishes on 2.67 seconds on it takes us the ratio 0.24 seconds. Rank 6, it's inner ranking of this severity, how important it is or how severe it is. It doesn't have to do anything with rank of system tree. So, but having this information, one can open Vampire, for example, or Blade, and scroll to this seconds 2.4 to 2.6 and find this late sender configuration, and maybe then understand the origin of this pattern. Maybe there is one rank performs exceptionally long computation, and therefore it doesn't send the data yet, and then one has one can address this problematic. The same thing one gets also if one clicks in a call path. Here, show max severity information, and that's basically the same thing. In my another video, which I will present you a little bit later, if one has a Vampire installed on a system, very same system where the cube is running, there is another standard plugin, so-called Vampire, and it allows us to connect CubeGUI with Vampire tool, and then it will be possible to select this pattern, go to this max severity, this pattern basically, and let the vampire show exactly this found configuration of late sender, so that one doesn't need to scroll manually to vampire. But that is the content of another video, so subscribe and get notified when this video gets released. Okay, that's all about this plugin. There is nothing more what this plugin displays, and the only probably one has to mention that the markers where the severity is found are displayed here using some small marker. Okay, I hope you like this video and you will understand what this metric statistics about and what does it mean, and that this gives you some insight in your performance measurement. Give us a like, subscribe, and comment if you have any questions, and see you next time.